Hello and welcome to Sean White's Solar and Energy Storage Podcast. Today we have Mike Bahtiarian. He is an engineer and he specializes in sound. I hope I'm sounding all right. Oh, what do you think, Mike? Do you like my low voice or my high voice?
Both sound good. Nah, the low voice is usually better. Right?
Yeah, okay, I'll try to keep it cool. All right. And then I think we could also talk about interesting things about sound, especially what we're going to be talking about is the sound of solar and storage and things like that. But a little bit more about Mike. Mike Bahtiarian is a mechanical engineer by profession. He has a couple of mechanical engineering degrees. He's a PE, that stands for professional engineer. I was looking him up too. He was the past president of the Institute of Noise Control Engineering. He won a Noise Control Engineer Award. He was on an ISO technical committee. He's the chair. All kinds of stuff. Looks like you've even worked with noise underwater on submarines and all kinds of cool stuff that I hope we could talk about. And it sounds like kind of just a fun topic to mess around with. So I was going to sound my voice off and ask you this first question here. What does the sun sound like? Is it yellow?
What does the sun sound like? I've never got asked that. I would imagine if you got close enough to hear it, you would be cooked. So I'll consider that question.
I wonder how that would go because, you're talking plasma and stuff, and I don't know what kind of medium. There's no sound in space.
And there's no sound in space. That's another piece, right? If you're in a vacuum, you have no sound.
But the people on the sun, I believe they have an atmosphere
Dude, I'd never heard
of
that.
some sort. I don't know. I'll have to call them up one more time and figure it out.
Or text, probably easier.
Yeah, I think they have Sunlink satellites up there.
So I appreciate that intro. I just want to make one small correction just for the record. So I am not a PE. I would love to be. I am equivalent to that. And maybe this is a good little thing to chat about. In acoustics, there's really no PEs. And the credential, because most of the states didn't have enough of us to bother with having acoustics PE. So I am board noise control engineer by the Institute of Noise Control Engineering. That's the organization I was a former president of. So there's a little plug for INS-USA and that program, which is really the only program in the country right now that would certify engineers in the field of noise control or acoustics.
Great. And then just once again, too, maybe I'll just mention how we came across each other. I was doing a presentation at RE Plus in Texas. That's the RE Plus conference, the regional one over in Texas.
Yeah.
And then I met somebody that you work with, Roberto Gomez.
Yeah, good old Roberto, who's hunkering down right now. I think he lost power and internet from Beryl.
Oh, bummer. Okay. Yeah, so Beryl's, of course, a big storm that just ran through, and that will be in the past for people listening because this is pre-recorded. And then so he gave a presentation on sound from a solar project. And I've always talked about solar as it's like doesn't make sound and stuff like this. And I guess compared to something else like a nuclear power plant or a coal plant, it probably doesn't make much sound.
Yeah.
And then I was thinking too, it's like, I've never heard a coal plant. Like, I don't go close to those things, but I imagine they're pretty noisy with all that spinning stuff. And have you been around a coal plant before?
Yeah, traditional power plant. I've been around quite a few in our area. Again, I'm talking to you from our Centec corporate office in Cambridge. So in the greater Boston, New England area, there's quite a few. I don't know how many are coal, but traditional power plants around here, mostly gas turbine fired, diesel fired, various, fossil fuel burning plants. And it's an interesting kind of dichotomy between these two because those plants generate a lot of sound. There's a lot of cooling that has to happen. And it's the combustion and the cooling that produces quite a bit of sound. They're probably not as big as you think, some of these smaller plants around the New England area, but they're big enough where there's a lot of space between the plant and maybe a residential property, which is mostly where, we're concerned with sound, where solar sites are now being located very close to residential properties. So even though they make much less sound, they're getting sited closer because there's really nothing else that's an environmental issue per se. I mean, there's things that, have to be looked at, but including sound. So that's kind of one of the reasons why, Yes, coal traditional energy production is much louder, but not sited nearly as close to properties as solar or battery sites.
Wow, okay, that's kind of interesting. I remember hearing some older inverters that made more noise than the newer ones, and perhaps that has something to do with the technology getting better. And then as the efficiency gets better, that means it makes less waste, and byproducts could be things like heat and sound. And I imagine probably sound ends up turning into heat anyway, like, which it's probably hard to measure or something like that, but when it bounces around enough, there's probably some degree
Yeah.
of it, not a lot.
Yeah, it's really, they probably go together. There's some energy, and whether that's being given off as a heat source or an acoustic source. Keeping in mind the actual amount of acoustic energy, when you're looking at it as an energy, in kilowatts or joules or things, it's very small. Sounds that can be heard audibly and distinctly as an energy source is like, you're not going to even light up a light bulb
Yeah.
with that kind of off emissions of energy. And you mentioned, at a solar site, the panels themselves don't produce sound. It's the inverters and transformers that produce sound. And in many cases, there is a process happening, electrical process, with some mechanical stuff happening that has sound. But many cases, the problematic sound is simply cooling of a transformer or cooling of an inverter.
Yeah, I remember in the earlier days, so we're talking like 15 to 20 years ago, residential solar was kind of big. And it was the fan, I think, a lot of times. And these days for residential, you don't often even see fans. And I think it has to do with they're a lot more efficient. And then the air just passing by can cool them off. And so we used to always say, don't put it on somebody's bedroom or anything like that. I was even wondering if one of these residential inverters without a fan to an extreme, maybe even a microinverter, does it make any sound?
Yeah, I would bet. So emissions of sound are relative to the existing sound level of the environment. So as your sound environment gets quieter and quieter, things do start to show up that you would never have seen. There's a couple stories of some test chambers for testing equipment that are so quiet that you go in, you can hear your heartbeat, you can hear your old watch, not a Apple Watch, but an old watch that's wound up ticking. Imagine that. I think of those things making any sound at all. But if you get in a quiet enough environment, these things produce some sound that are now evident, that are prior to that masked. And so that's kind of this environment that we're all in, and particularly a solar site in a residential neighborhood. You drive by during the day and you go, nice and quiet, don't hear a thing. And you don't realize that if you were to drive by at 3 a.m, and why would you drive by at 3 a.m? Probably not. But nearby resident is sleeping 3 a.m, might be able to hear the inverter. Maybe not a solar site, right? Because that's not doing any activity now that I think about it. But we're looking at some battery energy sites that we need to be concerned with, that 3 a.m. situation. That's typically the quietest point of the day for suburban or rural or, away from big cities, that kind of thing.
Okay, yeah. And I was trying to think about stuff like that too. I guess there's different noise ordinances, and you would know where the noise ordinance come from. I mean, would it be like local, state, federal?
All of the above. So what I could tell you, and we've been doing a lot of regulation review for our clients. So at the federal level, there are no regulatory limits for a solar site or a battery energy site noise. There was, back in the day, the EPA had some guidelines for sound in general, not for solar, for battery, obviously. This is something that goes back to the 70s. And so they have some guidelines. It's a document that was produced in 1973, 74, that was labeled sound levels commensurate for good health and welfare.
So it was just for everything, not
For everything. It's a
solar.
Hallmark report that said what isn't too noisy for people to enjoy their
So like
life.
boom boxes. When I yell, since my name's Sean White, they call that white noise. So,
Very good. Good acoustics joke. So that's federal. Now let's step down to the state level. Every state has its own code or not. Actually, that talk you saw Roberto give was originally given by myself at RE Plus Southeast, which was in Atlanta in mid-April. And in prep for that conference, we did a survey of all the southeastern states. So say from Virginia down to Florida, across over to Texas. And what we found is none of those states had a state noise regulation. Now, here where I am in the state of Massachusetts, we do. We have a fairly vague one. The state of Maine has a very good noise regulation. The state of Connecticut has a good noise regulation. So it kind of depends on the state. What we did find is that in the southern states, they actually had these codes at the county level. So you had to look at a county regulations to get what the applicable limit might be. Up here in the Northeast, there's really, the county level is just like a informal structure. I mean, I've never looked at any county regulations for the New England area, the mid-Atlantic area. However, we do look all the time at the local municipal town city regulation. So again, if you're going to assess a project, don't worry about federal, but you do need to understand state, county, and municipal.
So do they have different noise levels too for like the different tones or something like that? Like rap music with a subwoofer versus country music versus a solar inverter or a natural gas turbine?
Yeah, good question, Sean. So typically, the municipal ordinance has like a matrix of zoning. So residential, commercial, industrial, and maybe some other subversions of those different categories. And then a daytime sound limit and a nighttime sound limit. Some municipalities get a bit more sophisticated and they have daytime, evening, which is typically 7 to 10 p.m., and then night, which is 10 p.m. to 7 a.m. There's kind of some standard
I guess that would kind of
hours.
work well with solar because as the solar slows down, so goes the ordinance.
Yeah, so as it gets later into the night, the limits are lower. But all of those limits are typically a value called the shortened dBA. So it's decibels, A weighted decibels is the parameter. And there's this thing called the A weighting. So nearly all codes are in dBA, and the A weighting is a filtering that adjusts what we measure with an instrument to what you hear in your ears. So there's some special filtering that happens on an instrument. You can compute it mathematically if you have some certain types of data. And you talked about music. So some towns that have kind of thriving bar scene might actually have a sound limit using a thing called C weighting, which has much more low frequency contribution. So if you're trying to limit a bar and a nightclub that has like a lot of low frequency bass, the A weighting would be very insensitive to a lot of bass music. And in those cases, a C weighted limit is more applicable. And so I did a study many years ago for a little seaside town called Rehoboth Beach, Delaware. And they had a very nice club scene there. And they were kind of wondering, gee, we come out, we do this A weighting. It's really not that bad, but it's boom, boom, boom. I'm like, okay, yeah, because you're not making the right measurement.
So for all the bar owners listening, you want to move into a town with the DBAs, not the
Right.
DBCs, I guess?
That would make it a little easier for you until someone
Uh-huh.
caught on.
Uh-huh. Yeah, and then hopefully they don't change it mid-cycle and all that kind of stuff. And so maybe too, I mean, I know that you measure sound with decibels, and that's got to be what dB means. What's a decibel?
Another good question. So a decibel is unitless. The way I describe it, it's a fancy percent and it's a ratio. So actually what you're measuring sound in it is pressure. Sound is formally known as sound pressure level. Pressure is expressed in either PSI, that's the English unit, or pascals, that's the
So pounds per square inch?
yeah, so, but most acoustics uses pascals. For some reason, it's the metric version.
So it's like weight per area, I guess.
Right, it's the pressure of the force of that thing, the acoustic wave, over a certain area, if you want to think of it that way. So, in the instruments that we have, they have like a little microphone. The microphone gets the sound wave, impinges on it, and deflects, and it knows like, okay, that's so much pounds per square inch or pascals. And we get decibels by taking a ratio of what that pressure is and divide it by what's called a reference pressure. This is going to get technical here for a bit.
Uh-huh.
And then you take the logarithm of that and multiply it by 20. Easy. When it's in a spreadsheet,
Uh-huh.
it's easy. When you talk about it, it sounds super complicated. But the reason for all this is that the range of pressures that the ear can take or that we experience from really quiet to really loud is huge. And it's so large that like it's orders of 6 or 8 orders of magnitude, that using the decibel kind of condenses it down to something that goes from say 0 to maybe 140. So 0 decibels is basically the threshold of human hearing. The scale was designed that way.
So there could still be sound at 0 decibels, we just can't hear it.
Yeah, you wouldn't hear it. And there could be sound at minus 10 decibels somewhere in some crazy environment. Mathematically, there can be. I think practically it just doesn't exist. 0 decibels, middle of some desert, the dead of night in the winter, when there's no environmental sounds whatsoever. It's got to be just something that, or some test chamber that's isolated with no mechanical systems running. I mean, infrequent environment.
Like that chamber where you can hear your heartbeat.
Yeah, like something like that. But, just go up the scale a bit. 20 decibels might be a nice, very quiet suburban or rural night. We did some measurements for a year in a suburban town in our area. And the lowest measurement after 1 year was 18 decibels, 18 dBA.
The lowest.
So, yeah, after a year of measurement. Typical, go out a summer night, you'll probably find that the sound level is 30 to 40 decibels. And then, march ahead, the loudest things, the aircraft taking off, the Saturn V rocket taking off, that sound level at some distance, not right at the outlets, but hundreds of feet away, can approach 120, 140 decibels. And I'll give you an example. So the loudest environment I was in, I did a lot of work in my career doing shipboard noise. And the engine room of, say, a tugboat that's got a lot of horsepower in it is about 130 decibels, 130 dBA. You need double hearing protection. So earplugs, the little roll-up things in your ear, and then an ear muff over that. And if you are to yell in that environment, you cannot even hear yourself yelling. It's that loud. And it's, a little startling at first, but after a while, with the right hearing protection, you can, I've spent many hours in these loud environments doing work and testing and that kind of thing. But you do need hearing protection in that kind of environment. You'll damage your hearing pretty quickly, 10 minutes or more. So beyond that, 140, there's very few sources that would produce that much sound.
So when you're working with these solar and energy storage sites and you have noises, like you said, come from the cooling systems a lot of times, so we need to cool our inverters and transformers. And I guess too, with energy storage systems, we need to cool our batteries at certain times.
Yeah.
And so are we hearing compressor motors and things like that, like with an air conditioner? Is that a lot of times what we're hearing?
Yeah, that's usually it. But we're doing a lot of battery energy siting studies. And again, there really is no sound coming out of the battery inside these containers. It's the cooling of the battery and the cooling of some electronics. There's some smarts that goes with these things. So there's a bunch of cooling that has to happen. So it's either the air conditioning, condensing units, the air compressors, or sometimes just directly fans. Yeah, so some of these units have fans right in the top of the module, and that fan is moving air, and that produces sound as well.
So what kind of things do you run into with your profession? Like you'll have a solar site and it's near somebody's house, like maybe behind their backyard or something like that, and they complain, and then you come in and save the day? Is it something like that?
Yeah, that happens all the time. I'm a hero left and right.
Uh-huh.
So I'll give you an example. One of the probably very early solar field. So this is about 5 or 6 years ago. It was down in the South Cape Cod area, Massachusetts. Was built out fairly big. I don't remember acres or how many kilowatts, but an industrial grade solar field. They put all the inverters, all the equipment pads, there were three of them at this site, right before the fence to the project. And the other side of the fence was residential properties. And I would say the residential property was, I don't know, maybe 50 feet from the equipment pads. Just happened that, because some sound problems are not just a sound problem, there's a social thing happening. In this case, one of the abutters was a police officer, and the police officer worked the night shift. And so that means he's sleeping during the day, and he's sleeping when the solar field is doing its thing. And on really sunny days, the inverter would work a lot. And when it was working a lot, it had a cooling fan that ramped up and ramped down depending on the cooling that was needed. And you could just hear the sound, wind up and wind down from the fan in the inverter, because there's a policeman trying to sleep, 50 feet away. So imagine all the confluence of things that happen. Now, if we were to have evaluated that, and we were brought in after the fact to kind of help fix the problem, we would have looked at, like, okay, what sound comes out of the inverter? And when it gets to that resident, what level is it at? And is that compliant or not? And if it wasn't compliant, we would say, let's put a big sound barrier up. Or in this case, at this site, the unfortunate part is that the other side of the project was conservation land. So there's nobody over there. And the developer or the designer would have been very smart to have put all of the equipment, simply put it on the other side of the project. Wouldn't have cost anything on day one. At this point, with the project being built, they can't really move it. There's a lot of cables underground and it's expensive. So instead of moving it, we had to come up with some sound barriers that went around these three equipment pads.
So what does a sound barrier look like?
You see them all the time as you go up and down a highway. These walls along the highway are usually for sound if they're solid.
Okay, it doesn't have like a bunch of egg cartons on it.
Yeah, probably not. I know what you're talking about. So typically a sound wall looks, just a big wall that's typically made of a couple different constructions. And, there's a whole bunch of manufacturers of these systems. The most popular is a sheet metal sandwich with one side, the side facing the resident or the abutter, being solid, then inside being filled with maybe some fiberglass or mineral wool. Then the side facing the sound is or should be perforated. And that perforation absorbs the sound. If you have a situation where you have a wall here and a wall there, you don't want sound to hit one wall, bounce to the other side, hit the far side wall, and then go up and over. So these interior walls are sound absorptive, so there's no sound bouncing back and forth between the walls.
So just for instance, for that solar project, how high was the wall?
The wall in that case was probably about 12 feet.
And so on one side, is it something like concrete or bricks? Because you said it was like a highway wall. And so far, I haven't crashed into one of those yet to see what's in the middle of it. But the highway walls are brick or concrete or something like that.
Maybe that was a bad example. So typically the highway wall is a concrete construction, much more durable, lasts forever. If you bump into it, you're going to ruin your car and the wall will be there. And these kind of industrial systems I just described are, maybe 10-year life cycle. And if you run into it, you'd probably, just dent your car and really take the wall apart. So they kind of do the same thing. They are just different types. And you could use the concrete wall, at the solar site, but it might be overkill.
Okay, so then it's about 12 feet tall. How long was it or wide was it?
So in the case of a highway wall, the highway wall goes along the entire highway. And you don't see highway walls that have gaps in it. The whole thing has to kind of occur along the highway to get sound reduction from a highway. For a solar site with some fixed inverter, transformer pads, you'd probably just surround the pad. And in that case, you might do one side you probably need to do 2 or 3 sides to get all the performance right. But you don't really need to do 4 because, one side would be the rest of the project.
So like the length of the pad was like 20 feet or something like that?
Yeah, so like typical pad might be 20 by 20, and you would put the wall around, let's say the resident was to the north, you would put the wall on the east, west, and the north side, and maybe leave the south side open.
Wouldn't it be less expensive to buy them earplugs?
To buy that resident, yeah, I mean, buy them earplugs or change their windows. I mean, these are strategies that have been used for other projects. In Boston, when the big dig was happening, it's the big construction project.
Yeah, I've been in that tunnel many times.
Yeah, so one of the strategies was for when construction was occurring, they were buying certain residents right at the project air conditioners. So you don't have to have your window open for cooling. You just get an air conditioner and solve that temporary noise problem that way. So
Great. Okay. So what kind of decibel level, like just for instance, on a project like that, was the inverter putting out or approximately?
yeah, typically you're looking at something that's between, let's say, 50 to about 60 decibels at the project property line, at the fence line, so to speak. So at that level, it would be audible. It may or may not be compliant. Most of these municipal codes I talked about range usually like a limit around 40 decibels for night and roughly about 10 decibels higher during the day. So typically about 40 decibels night, 50 decibels during the day for a typical residential environment. And as you look at a commercial environment or an industrial environment, you'll see that limit jump up by, say, 5 or 10 decibels. So if it was 40 and 50, it might be 50 and 60 for an industrial environment.
So does sound go up by the inverse square, like radiation? So when you're twice as close, it's 4 times louder, that kind of thing?
Yeah, that's exactly the law, inverse square law. And we typically think of it the other way around. It gets reduced by the inverse square. So if you're at, say, 100 feet and it's 50 decibels, if you go to 200 feet, you're going to see a 6 decibel reduction. So that 50 decibels is now 44 decibels at 200 feet.
Okay. And that's like maybe double, or it would be 25% of the sound pressure, but decibels are on some kind of log type of scale. So it's not going to be the same type of numbers.
So
like
that's
that.
considered like a 3 decibel reduction is considered. So it's 3 decibels is about half the acoustic energy, but the average person perceives a halving of the sound, typically at the 10 decibel level. So if you were telling me, Sean, God, this music is so loud, I wish it would just be half as loud. You're kind of saying casually that whatever it is now, you want it to be 10 decibels lower.
Yeah, in my car, the volume goes up to 11. And I think that's from some Spinal Tap movie.
On the audio system.
Yeah, they're, turn it up to 11 and all that kind of stuff. We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSean, that's solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show. And so the sound that humans hear have to do with these things inside of our ears. So we have cochleas and basilar hair cells, hammer, anvil, and stapes. Man, I still remember biology class.
A lot of stuff, yeah.
And I think I went to this concert when I was probably about 20 years old, and they shot off cannons, and I lost hearing, definitely lost hearing.
You did?
From that, yeah. That kind of stuck with me. And so I guess you're probably an expert in all that stuff. It's like we have these little hair cells that move, and then they move relative to the eardrum, the tympanic membrane, and then these hair cells move, and that's how we hear. So it's not so linear, so maybe that's why the decibels are corrected for the way that we hear rather than just the mechanical sound pressure.
Yeah, so I'm not a great expert on the mechanics of the ear. I'm more, the mechanics of the stuff that making the noise. However, your ear is a very sensitive instrument with the ability to sense really low and really high sound levels. But, at the higher end, you do need to protect that ear because you can damage it. Unfortunately, in your case, it sounds really unfortunate that you had done damage. If you are exposed to kind of a moderate level of sound, you may have what's called temporary threshold shift, or TTS, where that's the go to the loud rock concert, but one that might not have cannons, and that night you go to bed and your ears are ringing. The next morning you're kind of okay at that point. I've experienced that a couple times.
Yeah, sure, I have too. Yep. Yeah, that band was called AC/DC. They're still around.
I know them. Yeah, I've had a funny case. All of us now with Apple Watches, there is a microphone in the watch, and it is listening. And I was recently at a Bruce Springsteen concert, and the warning goes off saying you're in a loud environment. I'm like, okay, yeah, but I'm Springsteen, so who cares?
I went to the Sphere in Las Vegas and saw the Dead and Company, the Grateful Dead, not too
Oh
long
yeah,
ago
yeah.
with my daughter.
Cover band or
No, it's got two of the original band members, and it has John Mayer in it instead of Jerry Garcia and some other guys. And it was pretty neat. Like, I used to go to a lot of Dead shows back before my daughter was even born. And so it was kind of neat to take her there. And one thing that I noticed, I was just seeing some chatter on Reddit, and there was a lot of people complaining about people that were making noise at the concert, and I wish they would shut up. And so
wow.
that means that it's not as loud.
Wow. I've never heard that or seen like so the people watching in a stadium environment were complaining that the guy next to them is making more noise than the rock band.
Yeah, they were calling them chompers. I'm not sure what that means, but it was about people like, I wish that guy would shut up. And I think they even took somebody out that was just bothering everyone. But from somebody that's experienced hearing damage, I think that was a good thing to lower the noise a little bit. But we also need to have other people be respectful. I went to go see the symphony in Sydney a year and a half ago, something like that. And I don't like loud noises anymore. I've been missing concerts because of that. And so I bought some kind of earplugs that are special for listening to music.
Yep.
And I didn't really use them. I tried them out. It did take away like part of the enjoyment. I did go to another concert. It was like a Christmas concert put on by Salesforce at the Pac Bell Park because my girlfriend works at Salesforce. And so they had a band there. And I tried just using regular earplugs, and it was not so enjoyable. It was just like I couldn't really
Yeah.
hear as much what was going on, but it was kind of neat. It was a smaller group for a big concert.
Yeah, I think there's two good strategies here. So the firm I'm with, Centec, we are chock full of really good musicians. We have quite a large number of musicians within our staff, and a few of them have got special musician hearing protection. So the device that's going in your ear, it's small, it's not like this headset or anything, is designed to have equal reduction in all frequencies, which means you're lowering the sound level and you're not distorting it. Because if the plug or the device lowers the low frequency and not the high frequency, you're changing what you're hearing, the nature of what you're hearing, or vice versa. So that's one thing. I don't know where you get these, but it's a
Huh, I'm
specialty.
interested. Maybe if we find out, we'll put it in the show notes.
I can, in fact, I'll ask one of my colleagues because he just mentioned it to me.
But it's electronic, I guess.
No, it's not electronic. It's a physical device with some kind of opening in it that blocks some sound. And
Yeah, that's kind of what I had, but it did take away some of the enjoyment. Maybe if you're playing the instrument, it makes it better, or maybe I just should have got a different brand.
yeah, and fit and insertion is very important. So that contributes as well to how these devices work. What I've been doing is I have the cheap little foam things that you have to roll up and put in. And what I'll do is, if there's something I'm like, okay, I don't really like that song, or I'll just take a break. So I'll put the earplugs in for some part of the concert, or if it gets really loud. But that's part of experience. You just don't want to hurt your hearing.
Yeah. Another thing I've done too is like switch ears with the earplug or put a
Yeah.
little paper in there, something like that. Oh, yeah. The band that I saw too in San Francisco at the ballpark is Maroon 5. It was pretty neat. I was like almost in the front row, when somebody hires a band like that for a party.
And those sound levels at a stadium, I would say you're probably looking at just somewhere between 90 and 100 decibels in an open air stadium. At a club, much smaller space, and the interest, so that you're not just hearing the music but you're feeling it, can go over 100, sometimes 110 decibels. That's quite loud. And for those of us that are a bit older, I used to enjoy it and love being in that environment. But if you're elevated in age, you may find a night of that to give you a TTS, so you're going to have some ringing when you get home, and that should be temporary. But, I think there are cases, yours, I've heard of others, that just get too close for too long and it's just too loud, and there is a limit.
Yeah, and it's certain places where I can't hear well, which is like parties, stuff like that,
Yeah.
where there's like background noise and people are loud and then somebody's talking next to you and I'm the guy that doesn't understand what they're saying. But I remember when I was in college, we used to joke around all the time and we're like, yeah, let's start a band, call it Sternum Rock. And we'll just have like bass guitars and drums and it'll shake your sternum. So probably not a good idea for your ears, doing any sternum rock. It shakes the sternum. Yeah. And so maybe we could head back to renewable energy. Have you worked with wind?
Yeah, I have done some wind siting evaluations, and I've worked in those cases. I've done some work at the community side, which is kind of unfortunate because clearly it's a renewable source of energy. And there was, in this part of the country, a very early interest in the 2010s to put some wind turbines up at the municipal level that were really not sited well.
Were those the ones that I think Teddy Kennedy was against? I remember there was some offshore wind that he was against.
No, they were not. The ones that he was against was an offshore wind project. I think it was called Vineyard Wind. I don't want to say the wrong name, but it was right in Vineyard Sound. And, the complaint was you'll be able to see it. Really, it was not an audible issue. It was just a view shed issue. And since then, the offshore wind projects in Massachusetts waters are much further offshore so that you won't really see it from land. But these were maybe 2 or 3 wind turbines on land. Typically, what was happening was the municipality had like a plot of land where they did their recycling center and their wastewater treatment center, and they would put up an industrial grade wind turbine. But these facilities were moderately close to residences. And in this case, it's like not right on the fence line, like that solar project I spoke about. This is 1,000 feet away from something that's like 400 feet in the air. And I have a couple of clients that we helped defend the complaints to the municipality about the excessive, although not very loud by just A-weighted standards, but the problematic sounds they were being exposed to.
Uh-huh. And so a wind turbine, I can't even really think of what it sounds like right now. I know I've been around some of them. Is it sort of like woo, woo?
Yeah, that's exactly what they sound like. Yeah, good imitation. So it's basically the blade cutting through the air, and in the right or wrong conditions, they'll make more or less sound depending on turbulence and the wind, a thing called wind shear. So that's when the wind varies with height. And so the blade is cutting through a higher velocity wind at the top and a lower velocity at the bottom of its, swing, or vice versa. And that creates a lot of turbulence and a lot of additional sounds that are, there's audible sound that comes off of that. And then there's very, very low frequency, what we call infrasound, that has been linked to kind of symptoms that maybe mimic seasickness, getting nauseous, getting agitated and anxious. There's been no, medical diagnosis of that, but there's a lot in written documents that talk to that.
Infrasound, would that be sound that's outside of the human hearing range? Like a dog whistle or something?
It's at the low frequency. So your hearing goes from about 20 to 20,000 hertz or 20 kilohertz. The dog whistle you won't hear because it's ultrasonic. It's higher than 20 kilohertz. So you don't hear it for that reason. This is the other side of the sound spectrum. It's below 20 hertz. And so you don't hear it because it's too low in frequency. I've made some successful measurements of infrasonic sound from wind turbines. It's actually at less than 1 hertz, which you just won't ever hear. Yeah, it's not something you're going to audibly hear, but you may feel it. Yeah. And that's basically what's the frequency of the blade going by.
Oh, it takes about a second for a rotation or something like that?
Yes. So it's about 0.7 seconds, actually.
Uh-huh.
And so you have that part of it. There's some audible sound that's in the mid-frequency range, but it's day and night. It envelops a house. Unlike the inverter, it might bother you at the front of your house, but if you go to the back of the house, it might not bother you, because you can get away from it because the source of sound is physically small. And it's mid-frequency. The wind turbine, that acoustic energy envelops the house. If you hear it in the front of the house, you're going to hear it in the back.
Oh, uh-huh.
It's also low frequency, which penetrates buildings much better. So, any building, any structure, its high frequency sound gets attenuated much better than the low frequency sound.
Yeah, I guess that would be like a longer wavelength could penetrate the structure, just like with cell phone signals and stuff like that.
That's exactly what happened. So you put all these things together and what can be a problematic environment. And like seasickness, you go on a boat with a number of people and boat's rocking around. Some people will get seasick, some people will not. Why do I get seasick and you do not? It's something bad in my body or, good in your
So
body.
if I don't like my neighbor, maybe I could get a subwoofer with a 1 hertz wavelength and then aim it at my neighbor's house.
As a board certified noise control engineer, I can't attest to any.
Or I'll go bring
bothering
it
neighbors.
to Cuba and shine it at some official's house over there because we've been hearing they've been doing things.
Well, I'll give you one point. You won't find a subwoofer that goes that low.
Oh,
The best subwoofers are probably getting down to 30 hertz or so.
I have to make
There's some
my own.
mechanical ways to make 1 hertz sound, acoustic energy. I don't even want to call it sound, but it's something very odd.
Is there anybody that looks into transmitting energy with sound? I know like we could do it with microwaves and things like that. I know you said there's not a lot of energy in sound. Do people ever consider that or anything?
I've never heard it. I don't know of any research, and I don't know how well you know your history. The last guy to talk about transmitting energy, not necessarily with sound, but transmitting it wirelessly, was a guy by the name of Nikola Tesla. He was not successful with any of that. I don't think anyone has been since. So
Yep, he's a pretty cool guy.
he did some cool stuff, but that part he failed. He was understanding that there was an ability to transmit signal, okay? Meaning, what we do now all over the place. And the guy who actually did that is a guy by the name of Marconi. Tesla thought I could transmit wirelessly signal and power and electricity, energy. He had some test site in Colorado, and then he built a really big one in New Jersey that has since been taken down. And neither of them he got to work.
I know they're doing space-based solar power and using microwaves to send electricity to Earth. So we do have the technology.
I never heard that.
Yeah, I actually wrote an article on a company in Solar Today magazine called SolarIn, and they've been working on this for a long time. They even had a contract with the utility that's right where I live, right here at PG&E, but it didn't go through. And I believe right now, like the government is doing some research on that too. So it's
What was the term, Sean?
space-based solar power, SBSP. In fact, I should do a podcast. I should call that guy I interviewed back and see what he's up to. But I believe that the government's doing some right now, and they've had some successful tests and things like that. I think they don't do it on Earth really through microwaves because just wires are a lot more efficient. And then it would kind of heat somebody up if they got in the way, or, there might be different ordinances or things that you might have problems with. But the whole idea was they beam it down to Earth and they could shoot it into a different location, like say if there's less demand here and more demand there, and it works 24/7. There's no clouds up there. And the microwave is a certain wavelength where it's longer than a raindrop. And so it can go through weather, and they could transmit the electricity with the microwaves any time of the day or night, and any kind of weather.
You could send energy anywhere. You could send power to the top of Mount Everest.
Yeah, and they were talking about seriously doing it for powering people on the moon when we start hanging out there more often than 50 something years ago. And so with the moon, they could use a different wavelength because they don't have weather. So I thought that was kind of interesting too. And then there's always, is this going to kill people, or is it like some kind of evil defense weapon where you can start microwaving people? And he said, oh, it wouldn't work too well. A laser would be much better. And if you flew an airplane through it where, you wouldn't, the metal would protect you apparently. but they would divert flight paths around it. And it was kind of interesting too. It would be like a field with these collectors of microwave, which is just a different spectrum of light, really. And they collect the microwave, turn it into direct current, and then it turns it back into alternating current with the typical inverters that we use today. And they would put these satellites that are collecting the sunshine at a geosynchronous orbit. And so they'd be a lot farther away than things like, space station and stuff like that.
Interesting. This is the first I've heard of that technology. So
Yeah, it's
I stand
pretty
corrected.
cool.
Yeah, there's a lot of neat stuff out there.
So another thing I was going to ask you about is like O&M, operation and maintenance. So is that a concern that you're dealing with? So like if they're out there cleaning things or even building things, or the noise from building the project, or the pile drivers would be a big one. Those things are really noisy. Have you worked with projects that had to dealing with that? Or a lot of those big projects with pile drivers are probably not anywhere near where people are.
Yeah, so we do occasionally, part of our scope is to look at the construction noise impact of the project. The thresholds for the noise limits are usually a bit higher. Some communities, they have noise limits for steady state operational sources of noise, and then they have noise limits for construction activities. And so we'll look at like what's the phasing of the project and how many different pieces of construction equipment and what is that noise, and does that kind of comply, and can we do some engineering or administrative controls, that kind of thing. It's construction, so it's temporary. And actually a solar field doesn't really need the noisiest equipment. And you probably know better than me, but I joke around and say, yeah, you could build a solar field with two guys in a pickup truck. You don't need big cranes and backhoes and things like that. So
Yeah, I thought of doing that in my spare time or when I retire, do like a kilowatt a day for 3 years, 1,000 days, and then I could do a megawatt all by myself.
there you go.
But yeah, the pile drivers are pretty noisy. I was just thinking maybe they could have like a mobile sound wall that follows the pile driver.
That's exactly a strategy we have. And, so that when you're at the far side of the project, if the residence is on one side, you might not need anything. As you get closer, you might need this kind of mobile wall, depending on the activity.
So I didn't even know they have those. So I guess they have them.
Yeah, back to the Boston's Big Dig, they established these mobile walls. That was basically a Jersey barrier with 8-foot posts that had a noise curtain on it that you could just fork truck, lift up, move into place, and move around. And they had these all over the place.
A Jersey barrier that keeps the Jersey people out of Massachusetts.
Well, yes, although I'm a Jersey boy originally, but I'm very glad to be a New Englander. So yeah, the barriers along the highway.
Oh, okay. That makes sense. Lots of highways in Jersey. Yeah. They say in Jersey, you tell people where you live by the highway exit.
By the highway.
I think it's the most densely populated state, I've heard.
New Jersey? You go to southern New Jersey, it's farmland. Jersey is the garden state. Like there's a lot of farmland below like the Newark area.
But I guess there's lots of wilderness in every state, really. Right?
Yeah, Massachusetts, everything past 495 is kind of quiet. But I was at Boston, Atlanta, and a lot of the vendors there are construction companies. And I thought that, the posts and all the things that have to go in the ground are actually drilled in with like giant drill bits versus pile drove in. So it's a quieter operation, equivalent foundation for solar panels. And
yeah, I would bet that most of the solar in the world goes in with pile drivers.
okay, I saw a lot of these big
Screws.
Diameters about this big, and you just twist it
Yeah, the
into
earth
the ground.
screws, the ground screws, and stuff like that. Yeah, and I think for like the really huge projects, the screws might take more time, and it's harder to make them go straight than a pile driver, especially if they hit a rock or something like that.
Yeah.
And then I guess you would have drones buzzing around doing O&M, shining infrared cameras. I don't know if they make much noise.
Yeah, the things we've done, we haven't really concentrated on operations and maintenance. In some cases, we look at, okay, what's this thing going to sound like in 10 years? And, equipment, as it gets older, it gets kind of noisier. We had some data that showed there was like a 5 decibel increase over so many years. Can't remember the specifics. But typically, what you get on day one is what you're going to have. And the only O&M thing that we might really look closer at is if there's a backup generator involved. Maybe not so much in a solar project, but many of the buildings we look at, those have to be operated. They operate when there's power, but they also have like a weekly maintenance operation. So we look at meeting that code for that type of operation.
Okay. And so I had like this weird idea. So I have some noise canceling headphones. And could you do something like have two different compressor motors, because that's the most of the noise I think that we're talking about for cooling these projects, put them out of phase with each other and make them cancel the noise like that?
So theoretically, that's all valid. There's nothing wrong with your logic there. The difficulty is that, getting two mechanical devices to be exactly out of phase is difficult. I don't know how that would get done. They have to be linked together somehow and operated together with some kind of, phase matching of the two. Then, if you could do that, and there's an example of that where that gets done, you still have three-dimensional space for this canceling to occur. So if you magically can get the two compressors to be out of phase, you might cancel sound at a point somewhere, but you might not cancel it everywhere. So
Oh,
this whole notion of active sound cancellation is fine. It's great. It works very well in a set of earmuffs because the space is just so small. Works very well. I mean, I got a pair a couple of years ago, and it's kind of a game changer when you're on a plane. And it would be very effective for inverter noise, a sound that has a specific frequency. But practically speaking, I think from what I've seen, that the active cancellation product line has diminished in the last 20 years. Meaning a lot of people got into it. There were some active mufflers and active HVAC silencers, and they don't exist anymore. They were not successful products. The headphones are going gangbusters. Everybody's got them. They're great. So no one has yet found the way. There's a couple problems. The math to do the canceling in random 3D space is highly complex. And take an open 3D space and you've got like something happening. Now you bring a truck into that environment. That adds a whole reflection that you weren't looking at before. The whole thing is now invalid. That's one. Two, you have to have enough energy to cancel. These devices have pretty big amount of energy. So you have to create that much energy to cancel it. So you'd be using a bit of energy to cancel it. And a three, I don't know how you would get two compressors to run exactly out of phase with each other.
I wonder if they could like share the same drive shaft or something like that.
Yeah, that's one way, right? And have one going opposite. So one of the places you'll see, and this is not for active cancellation. So on motorboats, on ships that have propellers, shafting, some of the higher end recreational craft with two shafts will sync the shafts. So they have sensors on it and they would sync them to be in phase and at the exact same speed. I think actually all they do is they try to get the exact same speed. And that gets rid of droning. So when two shafts are running slightly different speed, like a tenth of a RPM off, they drone. So it means
I
that
know
they
exactly what
actually
you're
beat,
saying.
right? The beating is the technical term for it. They go, it's like, oh. So you hear this droning coming and
Uh-huh.
going. When they're linked, it makes the same amount of sound, but there's no droning. So you don't get this like up and down in the volume, which is a very annoying sound. That's basically what a siren is. It's a warble. It's changing its
Oh,
frequency.
uh-huh.
And maybe that's more changing amplitude. Anyway,
Okay.
it's just a varying steady state sound that doesn't change in frequency or in amplitude. After some time, your ear, you kind of ignore it.
Okay, great. So before we finished, I thought of a question to ask you. So I was seeing that you have worked on some submarines for the military. And what kind of top secrets can you share with us that would get you in trouble?
This is very funny because I was on another podcast about a month or two, ended with the exact same question.
Oh, yeah.
And so if it was truly a secret, I could not divulge it. I
Uh,
did hold a clearance and we did basically anything related to the sound and the frequency of those sounds were all classified. And we had, catalogs I mean, I can't tell you the classified stuff, and I also don't remember the
Oh,
classified
come
stuff.
on. Yeah.
But I can tell you what was classified. We had catalogs, so we had books, this thick, of every prior submarine, page after page after page of data from each piece of equipment in the submarine. So one of the things they would do to make sure the submarine was operating quiet is as it was being built, it's in the shipyard, but in the water, and they would do these tests where they would run each piece of equipment one by one, and there were hydrophones along the length of the submarine that they would then measure that sound and categorize it. So every little pump by itself.
Because you want to be able to sneak up on the bad guys, I guess.
Well, so we want to know, like, is something making more noise? The Navy and the shipbuilder would want to know, is something out of spec? But they also want to know, like, what does each thing produce for sound, so we understand what this ship is doing acoustically.
So did you get to go riding a submarine underwater and stuff?
I did not. I spent a lot of time on the submarines that were built, but I did not get to go out at sea. I had quite a few colleagues that got these rides, and they were quite exciting. They come back with some big stories. Later in my career, things I can't talk about, we started working on commercial ships and particular research vessels. So civilian manned and operated research vessels that are being quieted for the ability to use sonar better. So they're using sonar to do bottom mapping, to do fish finding. And so if it's a noisy boat, then the sonar doesn't work as well. And so I was able to then go out to some of the labs that the Navy operates. One is in the Bahamas and the other one's up in Alaska. And it was a really fun and interesting thing to see the facility. Again, as a civilian, as an unclassified civilian. And there's a lot of work. I mean, you bring that up, Sean. There's a lot of work for quieting commercial ships for marine life.
Yeah. I know I've heard about, that they're disturbing the whales and that whales somehow can communicate like crazy huge distances, thousands of miles. Is that work according to the physics that you understand?
Yeah.
Send a signal that far in the water?
Most marine life are using sound way more than sight. In some cases, they have no ability to see anything because it's too dark or murky. And so they're finding prey, finding mates, finding their offspring using acoustics. And with all of the shipping that's in the sea that constantly grows year after year after year, the seas are much more noisier now than last year or 20 years ago. Think about like an airplane maybe gets retired after 10 years in service, maybe a little bit more. Ships last about 30 to 50 years. So you just keep having more and more shipping adding to the fleet, much less retiring because, the ships have a much longer life.
Well, we need to convert them all into sailboats.
You are a very astute person, Sean. That is a technology that they have, sail assist. So a cargo ship could pop up a sail, and then the sail provides, say, 20% or so additional thrust. So that's that much less power that has to go out through the propeller. So if you can get 20% savings in fuel from sail, they're doing that. And you run the propeller much slower, that reduces a lot of the sound. So that is a strategy that we've looked at, and we're kind of hoping might be one of the mitigations for vessel noise, as well as improving fuel efficiency. But sorry, I had no classified stuff to tell you.
Yeah, we'll do some torture next time. We'll get all those answers.
Whatever I know is nearly 30 years old at this point.
Yeah, we're going to definitely violate the Geneva Convention when we get those answers out of you and all that stuff for The Hague and the International Criminal Court. And so let's see, is there anything else that you wanted to talk about today? And we could always have you back another time too.
Well, Sean, I thank you for having me on your podcast. These are a lot of fun. We talked about a lot of different things. There's so much to talk about in acoustics and sound and noise. It really affects like every field. That was kind of one of the things when people ask me why did I get into this. It's because you got to know a lot about acoustics, but you got to know a little bit about everything else. So, I have a little bit of mechanical engineering of drivetrain. I know a little bit about structures. I know a little bit about HVAC systems, about how buildings go together, surface finishes, and then you add on top of that, you need to know a little bit about people and many noise problems, the kinds of problems that might occur adjacent to a battery site or a solar site. There's a lot of physics, and then at the very last part, there's a people problem. There's somebody that doesn't like what they're hearing, that is up late or up early, or, kind of has a different schedule. And that's, I think, something a lot of people don't recognize, is that there's this people issue happening as well. And that's why you have solar sites and nobody complains, or everybody's good with it except this one guy who's like a mile away. Why is he complaining and nobody closer not? And there's probably a reason. Sometimes it's not a great reason. I don't want to judge anybody on this call, but there's that. You need to be able to understand that part of it. And that's what I've kind of understood over the years. And again, not to go too much longer, but I've found myself working at the industry side, working for the developers, and working on the community side. Somebody that's complaining and they're trying to fight maybe a noise ordinance issue. I will take on both types of work. So maybe, a future talk could be more about the community side of living next to these projects. And, what does that mean? And it might mean other things. It might be like, okay, well, I don't have that view of the open field I had anymore. So maybe you could have me on and somebody that does like a view shed analysis.
Sure.
Something,
Yeah, and maybe those people that are the complainers about noise, you just send them to the concert I went to a long time ago. Send them to some AC/DC concerts. They won't be complaining about noise for very long.
Yeah, you might not hear that anymore.
Get them front row tickets and stuff like that. Yeah, great. Well, I really enjoyed talking to you. It was a good conversation. You're fun to talk to. And where can people find you, get your services? What kind of clients are you looking for? All that kind of stuff.
Yeah, so thank you for the plug to our firms. One of the principals at Acentech, and our website's www.acentech.com. So Acentech's probably one of the oldest consulting, acoustics, noise, vibration, and then we have building technology services. We're one of the oldest, but we do come from the oldest acoustics firm, which was known as Bolt, Beranek and Newman. That name might mean something to somebody that's been around. Or BBN, they're across the street from us. They were the first in the country acoustics consulting firm. And we have about a staff of 80, so we can handle a lot of different projects. And we're scattered throughout the country with offices in Philly, Virginia, California, and we have staff in Texas and in Chicago. So I think our website's the best way to find us. And I would like to also plug, we are also members of the Institute of Noise Control Engineering, for which I'm still an officer. And their website's www.insusa.com, where you would see a directory of my colleagues and us and other resources, kind of maybe more third-party resources, like what is acoustics and noise and how to find a consultant and that kind of thing.
Great. Yeah. And I found out that you're also on LinkedIn. And so.
Yes, we're just connected.
Yep. And so thank you so much, Mike Bahtiarian. Thanks for being on Sean White's Solar and Energy Storage Podcast. To find out more, go to SolarSean, that's SolarSean.com. Get yourself NABCEP certified, or if you want, you could ask Mike Bahtiarian about getting INTS certified. That's the Institute for Noise Control Engineering. Is that right?
That's it.
Awesome.
Thanks for the plugs.